So we are going to start our new chapter today with chapter 6, lesson 1, talking about exponents and powers. The words are used interchangeably with these. So I want to start off, exponents or powers are really just a shortcut. It's not a whole lot of computation. There are some things that you can do, but it's a way to make things easier to write. So I have here 3 examples for you. This was a pain to write out, I'm not going to lie. There's also a really good chance that I could make a mistake if I was copying a problem, if somebody else was copying it, if I was trying to calculate. So we use powers and exponents as a shortcut. The number that you see is what will get written as the base, the big number. How many of those there are, 1, 2, 3, 4, 5, 6, 7, gets put as a little number that's kind of sitting up a little bit in the air. It's called a superscript. That means that 4 will get multiplied by itself 7 times. It's not 4 times 7. It's actually quite different than 4 times 7. It means that the base will be written out however many times the exponent tells you to, or the power. And you would read this 4 to the 7th power. All right, what about this one? Well, the number I see repeated here is 3. How many times does it happen? 1, 2, 3. So my little number in the sky is 3. 3 to the 3rd. Sometimes this is called cubed, the exponent of 3, and we'll talk about that in a minute. All right, this last one. This is the type of problem that this comes in real handy with. So which number is duplicated? 10. How many times does it get duplicated? 1, 2, 3, 4, 5, 6, 7, 8. Man, that was easier to write 108 than to have to write out all those 10s. So notice that this is all multiplication. And notice that the number repeats. If I had different numbers, I couldn't use an exponent. Okay, let's talk about some vocab. Here's an example that I have for you. The things between the multiplication signs are called factors. And we've talked about that word before, right? Factors are the things that you can break a number into, the pieces that will multiply to give you the answer. The big number is called the base. And for any of you who are familiar with cheerleading and stunts, either you or a friend or a sibling maybe, the person on the bottom is usually called the base, and then the person who gets lifted or thrown into the air is called the flyer. So you could think about the exponent, if you're a cheerleading fan, almost like the flyer, where this is your base and this is your flyer or your exponent or your power. We have lots of words to describe the same things. Okay? All right, a couple more things real quick with this. Let's take a number like 5. You can have an exponent of 1. What does that mean? That means I'm only going to write it out one time. Anything that has an exponent of 1 is that number because there's nothing else to multiply it by. All right? If you have an exponent of 0, and you might just have to trust me on this, the answer is 1. It doesn't matter which base you have. If the exponent is 0, the answer is 1. So let's do another one. Let's take, 423 to the first power, or to the 1, would be 423. But 423 to the 0 power is 1. There's a whole pattern that I can explain to you, but for right now, you might just want to trust me because we've got lots of little details I'm throwing out at you. All right? There's one other term that I want you to talk about. We talked about up here being cubed. I want you to think about that. If I have a cube, like a box or a dice, all right, that has length, that has width, and that has height. And if all of them are the same, that's where we get the term cubed from, because your length, your width, and your height, 3 dimensions, were all the same. Now, you might have heard squared. Well, think about a square. If it has the same sides, let's say 7 by 7, when I multiply those to find out the area in the middle, 7 times 7 is really an exponent of 2, right? Because the base is 7, and there are 2 factors that are the same, so we use the 2. So we say 7 squared, because 2 is going to give me a square. This is what we call a perfect square. And a perfect square is the answer of an exponent 2. Okay, so you can go through and you can say, well, 1 times 1, 2 times 2, 3 times 3, 4 times 4, and go through your whole list of perfect squares. 1, 2, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and on and on and on. All of those would be considered perfect squares because they're the answer of an exponent of 2. Okay, so one more time real quick. It's the basic vocabulary. Factors, base, exponent.